Good morning. Paul Ryznar from Op Solutions. It's great to be here today at the EWE 2015. My company is Op Solutions. We're based out of just outside of Detroit, Michigan. The systems that we're actually demonstrating downstairs for the show is called Light Guide Systems, and it's great to be able to present that to you here today. So I'll just go through real quick a business case for AR based on our experience. We're really involved in the manufacturing space and helping to error-proof, mistake-proof inspection processes in automotive and aerospace, medical, electronics, as well as assembly, training, and even part kitting sequencing. Talk a little bit about the real product that's delivering real results. We're in over 40 factories around the world right now with Light Guide Systems. We are basically working on a lot of different things, you know, as far as Light Guide versus different instructions on wearables as well as projector-based systems. Primarily, we're doing projector-based augmented reality, as well as key takeaways. So we're all about cycle time reduction here at Op Solutions. So we're going to fly through this pretty quick. Fasten your seatbelts, but look forward to maybe seeing you downstairs in our booth later on as well. What's the business case for AR in manufacturing? You know, if you look back and let's say you're the person assembling door handles on a Model T back in the early 1900s, your job was pretty easy. It was selecting a black door handle and putting it on a black Model T. And your 40, 50-hour a week looked very similar as you went through, you know, your day. But if you're assembling a vehicle, let's say you're putting door handles on a GM vehicle today in Oshawa, Canada, there's 5 totally different vehicles coming down that assembly line involving the Impala, the Camaro, the Malibu, all different vehicles in the different colors that go along with it. And it's not GM, but there are automotive OEMs that have actually delivered vehicles with the wrong color door handles on them, one color on each side. So that's just a great example of how AR can fit into mistake-proofing and error-proofing manufacturing. We're seeing AR show up more and more. You know, the digital 3rd and 2 has actually become an expectation now when you're watching a football game. We think this is very interesting, though, from a manufacturing standpoint, because this 3rd and 2 that's up here is very similar to these work instructions that you see on manufacturing workstations around the world, usually with an inch or 2 of dust on them. And the reason people don't like to look at them is because they have to look away from the work to get that information. No different than having to look away from here to get that information. You'll react much better to the 3rd and 2 when it shows up right where your eyes are focused and concentrated. 29 miles an hour on your speedometer is great information, but it's not the same as this 29 miles an hour when it shows up right through your windshield. And it's actually been documented that that will improve compliance to speed limits by over 50%, even though that exact same information, again, similar to work instructions, is sitting right down there in your speedometer. So that combines this right information, right place, right time, and it's really the first statistic around what AR can do by combining all 3 of those things. So really what we want to do with Light Guide is move away from what you see here with somebody looking away from the work to get work instructions, in this case building a jet engine, to what you see down the bottom where we're projecting an accessory belt routing right around the gears, and it's really right in front of that associate while they're doing the work and getting that real-time work instruction as a part of their normal workflow. And Chrysler is our largest customer, although we're doing work with a lot of other customers in different sectors. But this is their data, and they've actually allowed us to share this data. For training somebody beginning to end using Light Guide Systems as compared to their standard work instructions, for an assembly process, errors were reduced by about 80%, productivity improved by almost 40%, throughput went up. And for a very similar logistics type process, part kitting and sequencing, very similar results. So for the first time ever now, we're starting to get real data on what augmented reality can do for manufacturing processes where literally complex processes become just as easy as following the lights. This is our data architecture. Again, we're primarily a projector-based system. We think projectors fit really well in manufacturing to minimize any safety concerns, as well as being able to make sure that batteries don't need to be recharged, et cetera. And we've actually seen some examples of torque guns that didn't get charged and a whole assembly went down to be able to, due to somebody didn't charge the batteries on 3rd shift. So our hardwired projector will be mounted overhead. It's plug-and-play technology. We interface right in with a standard factory network. So if they've already got vision cameras there, they've already got torque guns, they've got PLCs, they've got MES systems, our technology just plugs right into that industrial automation network, getting downloads on what information needs to be projected on the vehicles or the transmissions or the engines or the pacemaker, for instance, that's at station. So our goal is that we're completely paperless and completely wireless at the workstation level. Here's a few videos that actually show light guide at work in manufacturing type applications. This first one, we're dynamically tracking for a very complicated sequencing process, showing somebody where to place sequence parts into these bins. If they go into the wrong bin, they get that immediate feedback with an X that's flashing right on the part. If they go into the right bin, they get a green. As you can see, he went from the wrong bin to the right bin. So immediate real-time feedback whether somebody went into the right part or not. This is inspecting a diesel engine block. This is on a high-volume engine assembly line. And here we're projecting a CAD image of a gasket, so they don't need to physically lay a template down anymore. That literally saves them about 7 or 8 seconds with every block that they inspect. And now, instead of third shift inspecting this block differently than second shift versus first shift, everybody is doing it exactly the same way, so it becomes very standardized. This is a masking operation, placing about 45 different masks on the underbody of a vehicle. Same type of thing. It has now become very, very standardized. This is O-ring assembly on a medical device, and we're projecting what part to pick, and if they pick the wrong one, we don't advance them to the next step. We measure that diameter of this part with a little vision camera up overhead, and only if it's the right part do we show them where to place it as part of a no faults forward operating philosophy. Torquing, here we're interfacing in with this wireless torque gun. We actually demonstrated this at the International Manufacturing Technology Show in Chicago, and wireless interactive augmented reality. This is on a headliner for a vehicle. If they have some tape that didn't get covered up the wire, we point it out with light guide, and only when they fix it does a red light go away. And then finally, just showing somebody on a vehicle if the gap is out of spec, where it needs to be reworked. And we're interfacing in with different vision cameras there as well. So really augmented reality for different vehicles on different products, as well as gauging engine blots, et cetera. So it's a real product. It's delivering real results for a lot of different applications. What's really interesting about this picture is this is actually Sergio Marchionne, heads up Chrysler Fiat worldwide as their CEO. But you can see off to the kind of the right-hand side of this picture, that used to be their standard set of work instructions. And they've moved these off to the side now, and light guide has become the primary form of work instructions. So it really shows a neat evolution, if you will, in this picture. And this is actually out of the local newspaper, away from standard work instructions toward what AR can deliver on the factory floor. This takeaway from this slide, just to hit the high points here, it's really, it can cut across just about any kind of a manufacturing process as well as any kind of a manufacturing product around the world. So we'd be happy to go through this in a little more detail with you on the factory floor. We're actually at the Digital Manufacturing Institute that just opened up in Chicago, just outside of Chicago, I should say, at Goose Island. This is May 11th, highlighting light guide for their augmented reality digital manufacturing assembly cell. This is Rahm Emanuel in the middle here, looking at light guide. Senator Durbin from Congress off to the right side, Bruce Rauner, governor of Illinois. Everybody was pretty amazed by what they were seeing on the AR side for manufacturing. And just to wrap up, the business case for light guide, a lot of our systems have delivered payback in months or even less, not even years. And the payback typically comes from higher quality. Standardized processes are now much more repeatable across different shifts, higher productivity, greater accountability on the factory floor, and it's just a tremendous training tool. And I think everybody in the AR space would agree with that. Here's why we think projectors are always going to be a great fit for the manufacturing floor. You can see as we look at different options for work instructions, paper-based work instructions, monitor work instructions, tablets, wearable eyewear, or projectors, there's really not one technology that fits in across all the requirements that manufacturers are looking for. Primarily, always should be on, no batteries required, should be interfaced to the factory network, safe and secure, hands-free, right information, right place, right time, lowest cost, and high flexibility. So there's going to be a fit in a lot of manufacturing workstations for all of these technologies depending upon the application. So it really depends a lot on what the customer is looking for from a mistake-proofing and error-proofing tool, and that'll drive the overall application fit, if you will. So key takeaways, we're currently installed in over 40 factories. We've been in business since about 2005. Our customers include a lot of world-class manufacturing companies you can see across a lot of different sectors. Typical lead time for a system is 4 to 8 weeks. Price range has been anywhere between 10 to 180K. I know it's a wide bookend there, but it really depends upon the content. Many systems have delivered ROIs in weeks and months rather than years, and we're always available to help superpower anybody's processes. So that's the whole overview. Did I get done in 5 minutes?
Well done. So questions?
Any questions? Yeah.
Yes, we have one.
So you're in a lot of factories. Are you satisfied with that market, or are you looking at other markets now to apply this technology?
Yeah, that's a great question. We're getting pulled into medical more and more. And if you look at what's happening in hospitals right now, they're adopting a lot of the same lean and airproofing practices that have been in automotive for years. So we're getting pulled into a lot of medical applications to help build a pacemaker every time, or make sure the right surgical instruments are kitted for OR. Lots of different applications there. So ultimately, we're a software-based system. It's really how you program our system to make sure that the right instruments are kitted for the OR or whatever it might be. Great question. All right. Yes, sir. Right, great question. So the time to translate the content, a lot of times we find can be less than typing up all of these work instructions, and it's more effective too. So we'll train our customers on how to program LightGuide, and we'll show you on the floor below how easy it is to program. We've actually modeled programming after some of the Microsoft Office products. So if you can put a PowerPoint presentation together, you're about 50% of the way to learning how to program LightGuide. And after somebody installs the first couple systems, they're self-sufficient. They can install and program it on their own after that. Okay?
Awesome. Thank you,
Yeah,
Paul.
thanks.